It's a great pleasure to have you here today, and I'm so excited to dive deep into what you're building. If you just go straight to what you're building and then understand why we need this, maybe as a starting point.
Definitely, yeah. So we're building rockets that deliver cargo to contested environments. So we fly suborbitally, point to point, at hypersonic speed to very distant locations, and we deliver very time-sensitive and critical goods.
You mentioned that you had your own experience and also your co-founder had a situation. Maybe to take a step back and to go back to the origin story, what was the moment? Also, how did your paths crossed and then led to build this?
Yeah, for sure. So my background is in engineering. I started my first company that was building satellite propulsion systems, and I started that pretty much 6 months after starting my master's. And so that kind of began as a sort of a series of happy accidents. So we were trying to get internships. Nobody would give us any internships. And so we decided to do this summer project. And through doing that, we ended up building a prototype of our propulsion system. It was very, very basic, but we realized that in building that we had a lot of potential to actually turn that into a company. And so we just kept pursuing it. And so that turned into my first startup that was called Porkchop Space, where we ended up, after about 2 years, launching a propulsion system onto the third ever rideshare mission with SpaceX that was on Transporter 3. And through that company is where I got my experience with raising venture capital, building a team, understanding how to do sales and all that kind of stuff. It was completely new to me. And so it was really, really fun. We ended up selling the IP from that company to another firm. And so I really enjoyed that whole process, but I wanted to, figure out what I wanted to do next. So I spent a year working at a company that was building initially supersonic and hypersonic UAVs. Like for the last couple of years, I've been very interested in high speed flight. And so I really wanted to get into that space. That company ended up shifting more into defense. So we were supporting the scaling of loitering munition production for the Ukrainian armed forces.
Mm-hmm.
And in supporting that mission, I had nothing to do with defense before. I didn't really have any interest in it. And just seeing how, in Europe in the 21st century, we had full scale war again, which I kind of thought was behind us. I think that was just a regression of society. I realized that it's going to be very, very important for people who have the means. So whether that means like being able to start a company or being able to be an engineer who can build solutions or whichever way you can contribute, should contribute. I think you have a moral responsibility to defend the way of life in which you live. And so I really enjoyed that mission, but after a year, I realized that I had more gas in the tank and I felt like I just had to do another company. So I had that kind of burning, I guess, will to do that again. And so I ended up spending a couple of months just talking to people, trying to figure out what exactly does that look like. I had a bunch of different ideas. And then I ended up getting introduced to my co-founder through the company that I sold my IP to. So I became pretty close with a lot of that team. And after the deal had kind of closed, one of the guys asked me, so what's next for you? And I sort of told him I had this like idea in the back of my head for rockets and like doing some kind of transportation and stuff, but I'm not sure about it. And he's like, hey, you got to talk to this guy. He's in California. He's sort of been thinking about some similar things. Just talk to him. And
Who said that, by the way?
speak.
Who was the first?
So it was a guy
ever?
called Jared. And so Jared, when he was at Small Spark, that's the company that we sold our IP to. He is a very good friend of my co-founders, of Jacob's. And so I'm very, shout out to Jared for putting us in touch. Really happy for that. But yeah, we just like spoke. We spent a lot of time in the beginning talking, and not just talking about the like ideas and technical stuff, but also like what our shared values are, understanding what the other person is. If you're to build a successful company, it's a minimum of like a realistic like 10-year investment of your time, blood, sweat, and tears. And so you want to make sure that the person you're building this with is someone that matches how you operate, what you believe in, what your values are. And we were aligned really, really well. That was the thing that kind of first jumped out at me.
I have a question on that.
Please, yeah.
It's one thing that we have our own images in our heads and then we speak about it. And the other thing is when the situation arises and then you need to stick to your values and the way that you operate. Like, did you guys give yourselves a little project or a kind of like trial period that let's build something together? Doesn't matter what it is, but like, let's just go ahead and do it so that we get to know each other more in action.
Yeah, we literally did that. So we decided to put together kind of a project, exactly that, to kind of figure out how we work together.
Mm.
Can we put together like a prototype and then maybe build a company around this? And so we did that. We put together we poured a lot of our like life savings into this thing. And so the very first version of it that we built, we go out to the test site, and all of a sudden this jet engine that we had before we were using rockets, it catches fire. And so we're both looking at a decent chunk of our life savings literally on fire. And I remember just like running out with the fire extinguisher and like blasting it out. But for us, that was a really good moment, because what we realized is neither of us started like blaming each other or shouting at each other, pointing fingers. It was very much like, okay, let's take a step back. There was like maybe, 5 minutes of silence, and then immediately, what are we doing next? How are we addressing this? How are we going to fix this? And I remember like looking back, and we tell this story a lot. Like that was the moment that we realized that it's exactly to your point, that it's one thing to say, oh, I have these values, or I believe in X, Y, and Z. It's another thing to judge someone by their actions. And at that moment, I was like, okay, I feel very comfortable going further into this. And like looking back, that is probably one of the main kind of points in our story.
Okay, nice. And also, I think it must really hurt when you say the thing didn't work is another disappointment on top. Your savings are burning together with it. Like, okay.
It sucks, because at that point we also didn't know if we were going to, be able to turn that into an actual company, turn it into like raising money. So it's really, really difficult when you are going through that tunnel of unknown, and you just don't have a light at the end of the tunnel. But that's also where, again, you look at what people's values are. If you truly believe in what you're doing and you believe in your co-founder, you also have to inherently believe that things will get better over time. And they did, of course. But that's exactly that. I think that's definitely something that I recommend to people. If you're building a company with someone that you haven't known for a very long time, it's a great exercise to just work together and see how it works. And maybe it just doesn't work out, and you guys aren't meant for each other, and that's totally fine. But the upside is effectively uncapped, so you might as well try.
I'm so glad you started with a story that is not just a success and glories, and at the same time, it's kind of like showing, okay, we actually started by failing, but then we failed well, and then we tried to turn things around. And then you also had the same experience. Jacob had it in the military marine time, and then you had when you were developing hardware, that you needed to be there. You needed to make sure the piece arrives there within 24 hours. And instead you grabbed it. And then can you walk us through that story and then the overlapping parts, so that everyone who is listening can understand, okay, this is why this matters? Because I try to explain, how did this occur to you? Not like just, okay, it's an amazing time now with thanks to SpaceX and the developments, but at the same time, why would I ever need this? We will get to that, but I think you get my point, right? Like the problem space. I'm trying to get us into the problem space.
For sure. I'll tell Jacob's stories. So he joined the Marines right out of high school. And so I think we're going to look back in like 50 years and realize that putting 18-year-old boys in the line of conflict is a very terrible thing that we've been doing. And we've been doing it for like centuries and millennia just because we had to. But I think with how warfare is becoming autonomous, we're increasingly removing young children. And an 18-year-old is still a child. It doesn't matter what the law says. Putting children into war is wrong. And so he was in the Marines. He was actually out in Okinawa, and a Typhoon Haiyan had swept through the Philippines at the time. And so they were basically tasked with providing as much relief and support and humanitarian aid as they humanly could to the people that were affected. And so one of the main kind of aircraft in the fleet that the Marine Corps have is the MV-22 Osprey. And it's called the Widowmaker because it's known for being very unreliable. But also it happened that when they were trying to respond, that they had a lot of birds that were downed. They had pilots that were getting fatigued. Obviously the weather didn't help. And so they were just not able to, at any given time, there's just so many vehicles that were not operational at that point, also just missing parts, things like that. And so the amount of help that they could provide was limited compared to what they could have done. And so that's where, for Jacob, the kind of earliest ideas of there has to be a better way of doing something like this started forming in his head. He went on to work at SpaceX then, literally building reusable rockets and working on the very first Falcon Heavy, kind of when they put Elon's car into space and landed the two boosters at the same time. He launched over 20 Falcon 9s during his time there, and Falcon Heavies. And so that's where he really started putting like two and two together in his head. And so my story was obviously like no lives were lost in my story. Mine was more from the commercial angle, which is when I was building my last company, as you mentioned, we were given very little notice that it was in the middle of COVID, and they were like, hey, we need your propulsion system like tomorrow, basically. Otherwise, we would have to miss that launch and wait for the next one. And for context, we were like students that were living off of like pot noodle effectively, just like, being very, I guess, determined to make sure that we got the propulsion system into our integrators' hands. We were like, okay, we're going to do whatever it takes. So the first step is obviously you contact FedEx, DHL, UPS, and you try and figure out, can anybody guarantee me like delivery in less than 24 hours? I don't care what the cost is. I just need somebody to like give me a guarantee on paper that it'll come. That did not exist. They were willing to charge us a couple of $1,000 to ship something like really, really small, but nobody could guarantee that. So in the end, I ended up boarding a flight, just transporting it myself. And so that was a 23-hour round trip. And I remember on the flights home, just being really tired and cranky, I started thinking about, how else could this be done? Like I started reading, I remember on the flight back, I was reading about introduction to hypersonic flight. I was reading about some of the rocketry work that was done like in the 60s about like transportation here on Earth. So it was just, whenever I get really pissed off, my first reaction is usually to try and like build a solution around that problem. And so that's when I started thinking about it first. And I put that idea in the back of my head. I didn't really think about it for a couple of years until one thing that did stick in my head though, is that especially when I met Jacob and we started talking, I realized that we had this problem where we needed something delivered really, really quickly. And we were a small startup that was willing to pay pretty much whatever it takes. On the complete other end of the spectrum of like sizes of organization is the US military, which also needed things delivered very, very quickly, being willing to spend more or less whatever it takes. And so you're literally encompassing the entire spectrum of all available enterprises, right? And that was one of the first insights that there's very likely a lot of people, and this is like before we spoke to customers, before anything like that, there's very likely a very large subset of people that want to have things delivered in minutes and are willing to spend the money that it takes to do that.
Depending on the criticality of the thing, right? Like
exactly,
they want the thing at the right time, at the right place, at whatever cost,
and it's human nature, right? Like if we used to take it as a, it was just like standard practice that going from Europe to the New World, when it was kind of discovered by not discovered, but when the colonials came, it took like a couple of weeks. And that's just what it took. And then airplanes came along, or then steamships came along and they cut that time down. And so airplanes cut it down even further, and so on and so on. And so it's just human nature that once costs become competitive, you inherently, all things being equal, you'll always go for the faster option.
Actually, before we spoke today, I was into more the shipments over the ocean, like the vessels and the military that they are using. So astonished to learn that in the span of 20 years, if I'm not mistaken, from 6 billion to 12 billion, the amount just doubled of the number of the things that are moving through ocean. And this is just ocean. And on top, it's not just the number of things are doubling, but at the same time, the velocity is also doubling too. And then it started to get into the rabbit hole of all this nuclear power, like enabled the aircrafts on the oceans, and then how do they have this base there, but then still run on electricity, and then I started to think about what you do, guys. And then in your situation, can you help us understand how exactly you build it, and maybe then walk us through the experience, like who decides? Let's have our first user in our mind, and then tell us the moment that they make a decision, this needs to be delivered to X within these minutes. And then how do you make it happen? And then what enables this to happen? That comes down to the product, actually.
Sure. So there's a couple of points that kind of fall into place. So the first one is that if you actually look at who sends things urgently and who needs things urgently, it's usually the same companies. So like it can happen like last minute that a random company needs something. But if you actually look at, I'll give you an example, like an automotive plant. Automotive plants generate a lot of cars per hour, so a lot of value per unit of time. And so 1 hour of downtime can cost them $2 million. That's like a very commonly kind of known number. And so that means that on the receiving side, the automotive plant is very likely and very frequently going to be needing last minute things to be delivered. You can have inventory, you can have a lot of things, but you can never fully fix this problem. And so you look at kind of on the receiving side, you're going to have a lot of companies that are doing this. On the flip side, you also have companies that build high critical things or very time sensitive things, not related to automotive, for example, is companies doing cold chain logistics. So if you're building drugs or any sort of things that need to be stored at very low temperatures for certain amounts of time during transportation, you kind of know that they'll be shipping things out really frequently, and they just want to get it out to the end user's hands or the customer's hands very, very quickly. I know these are separate examples, but just kind of framing where the thinking comes from is that the way that it's done today is that you always have the kind of first mile, last mile in between. So like from the automotive plant, there's always going to be a part that goes to the nearest airport, and then a van will pick it up or a truck and drive it out to the other place. If we can, and that last mile actually accounts for usually a very large, like asymmetrically large percentage of the overall cost of transportation. So what that means is if you can cut down the, I guess, time and the space between the last mile and the mid mile, if you can effectively eliminate it, that would be a very good thing. Same goes for the first mile. If I'm like, again, shipping out my things, I will go and hand it over to the courier. They're going to drive in a van or a truck to the nearest airport. And, so if we can do a fully point-to-point solution, that's kind of the holy grail in what you're doing, that you're going straight from the sender to the receiver. And so one of the implications of that is that you can't just have a runway. You can't have like a massive airport and air traffic control and all that kind of stuff. You need something much closer to a helipad. Helipads are obviously like much less footprint, a smaller footprint. You can kind of take off and land vertically. And so we really looked at the helicopter model for kind of what is the precedent for what we're trying to build. And so with all of that in mind, the way we look at it is we have our vehicle where the payload bay is on the lower part of the vehicle. That's very intentional because we want to be able to come in with existing equipment. So things like forklifts and other kind of tools and equipment that are available today to actually load things onto the vehicle much faster. Be able to take off vertically with our rocket the same way that every rocket takes off. And then we follow what we call a hop curve. So that's why we're Hop Aero. So we fly this kind of ballistic trajectory. And that's actually the fastest way of going, especially at long distance. It's the fastest way of going anywhere on Earth. Faster than any supersonic plane, faster than anything, because you're literally leaving the atmosphere and you're kind of suborbitaling.
Suborbital.
Kind of made up that word. But like you're not orbiting the Earth, but you're going through a part of it. And then you're re-entering. So there's a lot of engineering challenges there. Like there's, I could like talk about that for...
Kármán line? Can we call it the Kármán line? Like kind of a little bit above the Kármán line, right?
Yeah, so it's a function of how far you're traveling. In some cases, you're definitely going past the Kármán line. The benefit of that is that you don't go through the atmosphere. So when you're going through the atmosphere, you're just inherently pushing against a lot of air. That becomes more and more difficult the faster you fly. So if there was just no atmosphere, your problem is not solved, but you definitely can design your mission in a different way. So we fly in that kind of curve. And then when we're about to re-enter the atmosphere, we come in pretty hot. So like the entire vehicle needs to survive the re-entry into the atmosphere. And then at the final part, you decelerate enough. So it's very similar to how SpaceX lands their rockets. You come in, you decelerate yourself to be very, very slow, deploy your legs, and then you can land vertically. And so there's a bunch of engineering challenges there, of course. But we're using technologies that are all very mature and have all been tested. So it's not like we're trying to build a new form of propulsion system or very exotic thermal materials or anything like that. We're using things that very much exist today and are just applying it to a problem where we're not trying to put more satellites into space. We're putting more cargo to different places on the planet.
There are two scenarios. One is the commercial one. The other is the military, right? And for the commercial one, you still need to little bit of a kind of setup, I guess, or at least to tell people where is it gonna go from and where is it gonna land. The military one is the most interesting one because it could be anywhere, and especially GPS disabled places, those like the very, very tough environment. Let's take a look at the situation where you send it in the military scenario. And in the middle of nowhere, like how do you even know where to pick? And then how do you know that where you're gonna land? And when you land, like what are the things that needs to be check? Because it's an autonomous rocket, right? Like it's not like someone is like driving it. And then what's the system behind it? If you just break it down, the system for us, that will be super cool.
Yeah, so kind of I'll stick to the things that we've publicly disclosed. So we launch from a 40-foot shipping container. And so the idea is because our rockets are relatively small, that like Rook 2 that we're building, that's kind of our going to be our first product. we can pre-position that container that has the launch system inside of it. And so that pretty much means whatever flat surface you can put a 40-foot shipping container on, which is extremely common, you can launch a rocket from. And so from a military perspective, the huge benefit to that is that you have very responsive launch. It means that you don't need a massive launch site. You don't need, fixed infrastructure. The idea is to be very mobile. In the military, there's a saying called shoot and scoot, effectively. That's really kind of what we're trying to go for on the launch side.
So as long as you have space for the container, it's like basic container. What size of container we are talking about?
So it's 40 foot long. I think that works out to, I can't remember. I think it's 12 meters long.
Okay.
Something like that. So it's the most standard size of shipping container. It's like 40 foot long and then 10 foot by 10 foot on the front. And then we launch, as I mentioned, kind of vertically. We follow our hop. And then what we also kind of announce publicly is that we land on unprepared surfaces. Again, this is something that's been done for a really long time. People kind of forget, like the original landing on an unprepared surface is literally on the moon. It's like the most unprepared that it can be. Obviously, the moon doesn't have an atmosphere, but SpaceX has also been landing on prepared surfaces here on Earth. But if you look at companies like Maston Space, my co-founder used to work at Maston. They were landing on sand. They were landing on some pretty rough surfaces. So it's definitely, again, I'll keep saying this, like there's a lot of engineering challenges that go into this, but it's very much possible.
But actually, like there are, in this situation, what are the things that the system looks into before making the decision? Okay, this is good enough for me to land here.
So there's been a lot of, I won't go into like exact details of our kind of flight controls and things like that. But one thing I will say is that the war in Ukraine has significantly improved the quality of avionics, sensors, and autonomy as well. And also not just improve them, but also significantly cut down the cost and increase their availability. So before the Ukraine war, for example, an anti-jamming GPS antenna would have been very, very difficult to get your hands on. It would have cost a lot of money and been a very long lead time to get it as well. And now there's probably like 24 companies that are building them really, really well. Same goes for cameras that are able to do onboard vision processing to, whether you're like looking for a target or whether you're trying to land somewhere. So we've definitely been tracking a lot of the latest developments and what's been going on in the kind of drone wars. And a lot of it is actually relatively applicable to rocketry. There's certain things that obviously you need to take from like how things were done before. But again, that's where SpaceX did a phenomenal job in kind of not buying from legacy primes, and they just built a lot of things themselves. And especially now with AI and how much you can amplify the capabilities of engineers, we can move a lot faster with a much smaller team that's able to build hardware at the same quality, rate, and capacity as was done by much larger teams in the past.
Speaking of AI that you mentioned, I assume you leverage it in your designs as well. But at the same time, I am aware that I can't ask so many detailed questions. And this is your little of secret sauce too. When it comes to manufacturing and when AI designs things, the geometry is very different. The way that we manufacture, it could be additive manufacturing or it could be subtractive manufacturing. And then how do you guys leverage these both options when it comes to manufacturing and the design part? And itself also, you have simulations versus reality test. That maybe then you can a little bit of like help us understand that piece. That will be great.
Sure. So yeah, bunch of different questions there. I'll start off with engines. So engines for the last, I'd say 10, 15 years for rockets have pretty much been 3D printed, especially in kind of combustion chambers and things like that, the kind of cooling channels, just because it's so much easier to do. And a lot of that was kind of because like digital manufacturing kind of became more commonplace in the last 20 to 25 years. And so even people don't realize, people don't give SpaceX enough credit. They've been using metal 3D printed engines for a while. Rocket Lab were kind of the first, I guess, really well known ones for this. But now it's kind of the industry default. I find very, very few teams are using any sort of subtractive manufacturing for things like that. So the really cool thing about where we are right now is that if you have a digital design process, and additive manufacturing is a digital manufacturing process because it's effectively fully defined that way, you can have you're a lot closer to a fully closed loop where you actually have, so the end goal here is like to have basically zero humans involved. You want to achieve a certain goal. You need to understand the physics, and modeling the physics of an engine is, a lot of things. You have thermal stress, you have mechanical considerations, metal, thermochemistry, all that kind of stuff. But ultimately, it's very much a science, not an art in some ways. There's definitely like creative solutions that you can think of, but like building an engine is a very well known and understood thing, kind of traditional engines. And so without going into too much detail, we've been building what we call Hop OS internally, which is our intelligence layer of the company. And the end goal for Hop OS is that we will always need humans to solve a lot of problems and guide things, but it's how do you facilitate at scale of the size of a large engineering organization the means for things like that engine to be fully defined in software, ideally tested and simulated in software, but also have a really good feedback loop from when you're testing it in real life, feeding that data that you gather back into the model and making sure that all of those lessons are learned. Traditionally, that would have been a really, really long process. You'd have separate teams and just a lot of human error and miscommunication. It just takes a long time. So these are all things that, we obviously didn't invent 3D printing or anything, but we stand on the shoulders of giants, and we've been really smart about how we leverage a lot of these things, especially going forward, trying to forecast what are the capabilities of AI going to look like in 6 months, 12 months, more, and trying to build Hop OS and the tools within Hop OS around that capability. So we're really, really excited about that. Actually, it's one of the coolest things about being alive and building a company at this time.
Actually, then in a way, you guys become the glue of the best practice. I don't like the word best practices, but the best way of doing things. So individually, then you try to connect it in your operating system and then try to run it in a more effective and efficient way, if I understood it correctly.
Yeah. So that was one thing that I learned from Jacob from when he was at SpaceX, is that one of the reasons SpaceX was so successful is because they had really powerful enterprise software tools that they developed and maintained themselves. So Warp Drive is the one that a lot of people know about. And that's
Warp
obviously,
Drive?
like
What is it about?
Warp Drive.
I haven't heard about it. What is it about? I haven't heard about it.
So basically, Warp Drive is one of several softwares that SpaceX built and use to effectively streamline a lot of their internal production. And I think it's like closer to kind of ERP. With Hop OS, our vision is a little bit different to that. But essentially, what we saw is that was obviously like, one of the reasons, again, Elon Musk was so successful with SpaceX is because he came from the software world and he brought a lot of those ideas into aerospace. We're at a very similar position today where the adoption of AI in aerospace is actually surprisingly low, considering we've had like very advanced AI for the last couple of years. There's definitely some companies that are, pushing the edge of AI in aerospace. But if you actually look at the average aerospace engineering organization, the level of adoption of AI is relatively glacial. And so we see this really, really great opportunity right now where we can come in and shove a wedge into that and make sure that we can outpace other companies.
Actually, one of the things that I realized, correct me if I'm wrong, the folks who have the hands-on experience in aerospace and they realize the wave that we are surfing right now in AI, they started to get super specialized in a way that they built, for example, I forgot the name. There is an amazing software company. They help engineers to design their engine, but they don't do anything. But this is like purely with the AI inside of it, leveraging it. And at the same time, the only algorithm that they provide them to make their life in their context better. And then it kind of started to surprise me to see it started to get even those branches all around. When it comes to testing, there's a totally specialized one. When it comes to designing the algorithm and software is totally specialized. In your situation, what sort of things you guys are outsourcing in a way that you collaborate, partner? And what sort of things that you say, no, we handle this on our own. This is our house, in-house.
That's a really good question. That's one that we have spent a lot of time thinking about. So the way that it currently works right now is effectively, we don't have a blanket policy. So we don't say we're fully vertically integrated or we're just partnering with everyone and not building anything and we'll integrate everything at the end. We look at it very much from a, it's like such an overused phrase, but like first principles, what makes ultimately more sense and how do you like work up from that? And so we'll look at component by component. For example, certain valves, you can just find them off the shelf and they'll do a great job. Other types of valves, you cannot do that. And so you might just have to build that yourself. And so we have no blanket policy, but we look at everything from, we make or buy decisions like standard engineering companies. So how much would this cost us to make? If we don't make it, what's the cost, lead time? How reliable is the supplier? even if suppliers check all the boxes and they can promise you very attractive prices, amazing lead time, all that kind of stuff. We've had so many cases where they just disappoint and they deliver 20% delayed,
Nice.
over budget, things like that. And so we've been bitten a couple of times before by depending on suppliers. So I think given AI, given a bunch of different things, given the fact that there's also a lot of vertical integration that's been done in aerospace in the last kind of 10, 15 years, I think that's where things are trending to in the long term.
Mm.
However, very importantly, we know that we cannot do everything in-house. It's just physically impossible if you want to run a tight team. And there's just some things that take time to develop and build. And so that's one thing that we've definitely tried to be really smart about. We're not trying to say that we're one way or the other. We try to just be very intentional about every single part and component.
Yeah. Also, probably that you always play to your strength, right? Because you don't have time to, like, how many of those things you can really learn and try to get done. Did you ever have a situation where you yourself were surprised with your learning speed? Like, oh gosh, like we had to figure this out on our own because, as you say, let's say Supplier was not reliable. And then we were like, okay, time is ticking. So let's just give it a try. Like, do you have a situation like that? Probably you did, but maybe if you
We have a
tell one.
lot. We have a lot. We have a lot. There's I'm trying to think of one that I can say publicly because like it's also like I understand when you're working with another company, they have their own priorities and goals and things like that. For example, one good one is like with valves. As I kind of mentioned, we were buying valves off the shelf, and we had it like in the invoice that it was going to be this cost, this lead time, whatever. They were very late. They came like maybe a quarter of them were broken, things like that. So that just like. It was just really unfortunate because we were in huge crunch time and just had to go and as quickly as humanly possible to try and find alternatives. I won't name the company, but things like that just happen. And especially as a company is larger, they care a lot less about you as a startup. And that's the other thing as well. You could think that what you're building is the most important thing in the world, but you also have to be
For
very
you,
realistic and
not for
realize
them.
exactly. So like just, putting any sort of like ego that you might have aside and understanding where do I fit in the food chain for these guys, that alone could just save you so much time and money. And just speaking with other founders as well, everyone seems to learn that lesson the hard way as well. That like for certain components, even if it's initially cheaper to buy it off the shelf, it can mess you up in the long term just by not having that learning and that knowledge. And we've had a bunch of insights that kind of come through, like to your point, that just by actually building it, we realized that the process by which we built it was maybe not great and that AI could automate a bunch of these things. So especially actually in software, I can't remember who I was talking about it with recently, but I think when it comes to SaaS products, like a lot of companies are finding it better to just build their own tools because not in every single case, but it's usually like you can solve, I'd say 90% of your problems by building it yourself when it comes to software.
And honestly, I really appreciate your blunt and honest way of explaining this. We all know as a reality that if you go to a big company, that you need to collaborate with them. And the very first thing happens is like, what sort of revenue do you provide them on the rankings? Where do you stand? Like, to be very like brutally honest with you. And most of the times whenever I ask founders, like in our conversations, so how do you make sure that you're gonna be one of the people who is gonna receive on time? And, oh, we know this, we have that, but I'm like, you're one of the very few, like saying in a very like honest way, yep, that actually happens too. And then we just need to find a way to turn things around and either build ourselves or then we try to buy time in the meanwhile. Thank you. That was really refreshing.
We're very open about like our successes and our failures. I mean, to the point about that jet engine, being on fire at the start of the podcast. You cannot build a company like this without making a huge number of mistakes along the way. And the only thing you can do is just make sure that you learn from them and incorporate those learnings and that it also goes into the culture of the company. And so whenever I fail at things or the rest of the team fails at things, like it's never, again, we don't have this finger pointing exercise. It's okay, what's next? How do we fix this? How do we move forward? So the same goes for suppliers. It's not, I don't think that suppliers are evil or anything like that. It's just, you have to be
No.
very real about the situation.
It's sometimes they say it's just business. Like there's this
Yeah.
cold saying, it's just business. Don't take it personal.
Yeah.
Yeah. Like Matija, I am having multiple questions, but probably I'm going to take a little bit step back to the differentiation of your product. Because if you take a look at all the alternative solutions right now out there are multicopters, there are drones, there are K-MAX aircrafts, and there are like, you know them better than I do. And then the range is very like from 60, I think minimum is 68 kilos to almost 3 tons. And depending on the solution, the range and the time you aim for, you guys seem to be the fastest by all means. But at the same time, what would stop me? Let's say I have a solution where I can send 2 tons of supply in the military conditions to the most help needed area. And if they just wait another 30 minutes or another 45 minutes, they're going to get even more supply versus I need to get your solution, which kind of sets into my mind, is it an outlier situation? Is it so exceptional that, because things need to be, I know there's no value we can give for a human being's lives if it is in war situations, especially. But can you help us understand, are we talking about the really infrastructure that's going to speed things up? Or are we talking about such extremely rare situations, but still critical? And no matter what, military is going to cover the thing. Like, I'm trying to understand, how do you guys want to make it sustainable? Not like one at I don't know what occasion.
Sure.
Do you know what I mean? Could I explain
Totally.
myself?
Yeah, for sure. So that was a multi-loaded question. Let me kind of break that down. So drones and like quadcopters and all of these things are phenomenal. I think it's like we're going to look back in 100 years and realize that drones becoming a commonplace thing has been a huge invention for society. But to your point, they are generally very limited in range and speed. So again, huge spectrum, but like very like the fastest drones, like interceptors, are reaching 300-400 kilometers an hour. That's kind of outliers. Most are kind of going less than 100 kilometers an hour. And then again, payload capacity, you're looking at
I'm checking my table. I have a kind of table here.
Just fact check me all day. That's totally fine. So like these things are great. Where like a lot of the benefit of these is it's basically within a city. So it's like the perfect solution for cities. And it's disappointing that we don't have more drone delivery in the world, but they're vertically takeoff and landing. They have relatively limited payload capacity, which is perfect for like safety. So if a drone falls out of the sky, the damage it can cause by carrying a pizza and a coffee is very, very limited. And it's vertically landing as well. When you're looking at a wartime scenario, one of the biggest things that you're looking at is actually the speed and the range. So at that point, you're not transporting something, like a couple of miles. You're in a lot of cases looking to go tens of miles, hundreds of miles potentially. And so you kind of have to fall back on what already exists today. Like you cannot send a cargo drone to deliver things hundreds of miles away because it just doesn't exist. The battery density isn't good enough. If you're using one with like a generator, like a hybrid system, it's kind of a mixed bag. And then again, you have the landing problem. Usually vertical takeoff and landing drones have very limited range because you spend a lot of energy going up and a lot of energy going down. Whereas ones that cruise are a lot more efficient, but you need a runway. With rocketry, you still have the same physics problems. So you still spend a lot of energy going up, you spend a lot of energy going down, but you do not need a runway, which is one of the main things in wartime. So I guess one way to think about us is we're kind of like a quadcopter on steroids that's able to go much faster and further. And then the other one is speed. And that's kind of the main one, which is that a quadcopter, as I said, can go relatively slowly in most cases, or multicopter. And that's relatively easy to shoot down. Like you can see like a million clips on YouTube of just soldiers shooting these down with AK-47s. With rocketry, you kind of get the best of both worlds. So you're able to go very, very far distances, on the order of hundreds of miles, and you're able to do that in minutes. And so from the wartime perspective, you're giving people a brand new instrument through which to deploy cargo. Now, to your point about like the actual like use cases and whether this is like an urgent thing or like whether it could be used at scale, this is where it comes back to what I said before about how low cost can we make these things. If we're charging, $10 million per launch, nobody will ever buy from us because it's just astronomical amounts of money. I won't go into the details of how much we're charging, but it's substantially less than $10 million. And also we see a very clear path to cutting down the cost in a bunch of different ways. Again, I won't go into the details of that, but our goal is to actually have a comparable cost per unit of mass or per unit of whatever compared to a lot of different solutions, such that, as I said at the beginning, if all things are equal and you just want to choose the faster one, you'll always choose the faster one compared to the slower one, because why would you? And as I also said before, there's a lot of engineering challenges that need to go into this. So the upfront development and the upfront capex to build something like this is obviously higher than a drone or a quadcopter, but the payoff is also much, much higher. The upside is much higher. And so as a capability, I think it's inevitable that every superpower will want this, will need this. And then it's like, who's going to be the first one to get it? So that's kind of how we think about that. And then if I remember, the last question that you had was, what's stopping, someone else from just building this thing? Because it's, I can't remember how you phrased it, but like, why can someone else not do this? I could come here and talk about, like, we have this amazing, like, we have Hop OS and we have this and this and this. We have like this different approach, but a lot of it is like, can you build a really good team to go out and actually design this? Do you have the team that has the grit to be out for, 18-hour days and test it on the site? Do you know how to operate a test site? Do you know how to, gather that data from the test team and then feed that back into the design team very quickly? Can you make sure that the test and design team are the same team? Can software accelerate any of that? So like I saw this tweet on X really recently that said being able to endure pain is the moat, something like that. And that's, I think ultimately what it boils down to is something like that. Like, you can be the smartest guy, and for sure, like, being smart here helps. But a lot of it is just, can you and your founders and your team be able to get kicked in the teeth every single day for years and just persevere through? I think that's ultimately one of the differentiators. And I would be willing to bet everything I have that there's not many people like that.
I think this is like, I sometimes make it, how do you say this? Analogy between relationships. That you start dating with someone, you start flirting, and then you phase into dating. And then in the beginning, everything is always great. Like, chemistry is always there. Like, everyone is at their best, let's say, behavior. But then the moment that life throws a couple of things, and then you get to realize, oh, hold on. Like, no, I don't want, no, I can't help you with this. And then I thought we would be a couple who is going to go through this together. That's also probably, nowadays, I never say like there should be always two founders or two co-founders needs to be in place. But honestly, I think it's a massive help. Like, even if it is not about pure technical and execution perspective, first you have a sparring partner, and the most important part, you're a human being in the end of the day. Like, you also have your own batteries that somebody needs to be covering for you, or saying, hey, it's all right. Like, just go sleep. Tomorrow is a new day. When was the last situation like this that Jacob or you were like, that's fine, let's close the shop today. Take a sleep. Tomorrow is a new day.
A lot. I'm a human. I don't know if Jacob's a human. I've seen him like do some crazy work for very long hours. I think like half of his brain is probably some sort of AI, something like that. He's a machine. He gets a lot of that from being in the Marines. That's also why in general I love working with veterans, because they're just talking to veterans as well. They tend to be some of the hardest working people that you'll meet out there. We have a lot of those times. So like, that's exactly to your point. Like, I think we've spoken about that. I think one founder of a company and you have nobody to kind of lean on when times are tough. If you have three founders in a company, keeping like three people in, three is a crowd, as they say. It's not, two is a pair, three is a crowd. I think having like that level of communication with three founders is actually difficult, and the number of relationships that you have to manage with like co-founders increases, I think, proportional to the square of the number of people. So it's just like
decision making also gets trickier.
Exactly.
Right?
And so the cool thing about our setup is that obviously I'm technical, but I'm the CEO, so I'm responsible for pretty much everything non-technical. I get the final say on all of these things. For Jacob, he's the CTO. He gets the final say on all technical things. However, him being a veteran, having experience with the military, gives me a lot of insight into what I'm doing, and he can also kind of be a sparring partner. And same for me, I'm able to help out a lot on engineering and kind of, be a fresh pair of eyes in certain cases. So that's also what I love about our setup, is that we're not, I'm not like some business guy that just kind of said, yeah, let's do whatever and make the rocket go faster. It doesn't matter how, just make it faster. Like having, and same for him. He was like, just
what
go.
It is. Right?
Yeah.
It's not that you don't understand what it takes to build that. That's why like you can't just say, I don't care. Now by noon, I want this done.
Exactly. And same for him. He can't just like, he understands how government contracting works. He know that it's not just like, well, it's 1 p.m. already. Why don't we have a new contract? So it's like that mutual understanding has been a very important thing for us. And it also carries down to the team as well. Like we are, obviously we're a very technical company, and we make sure that the people we bring on are technically very, very good. So that's been a very important kind of part of what we do.
I remember in the family, we used to say a lot soldier mode when anything, let's say you're not in your mood or you're sick, but there's something super important that you need to deliver. That's why it comes from, I think, this discipline with the military background people is a different level that I can confirm from my own experience. No, Nihai, soldier mode, you push through. And actually you feel very proud, like afterwards, like that. Oh, I didn't know, I had that energy already. Really cool to have such a mindset in place in where you're building. Speaking of the faster, because faster rocket means, okay, velocity is higher, but then immediately that drinks up the fuel. Can maybe a little bit tell us how you fine tune those balances? Because sky is the limit when it comes to setting higher targets. You also guys publicly said that you completed your testings. There was sort of things came to your mind that those were the trade-offs, versus perhaps speed or perhaps how much load I can bring in.
Yeah, so we very much optimized for what we call door-to-door speed. So if you think about like, this is when the user wants to send something, and this is when the other user wants to receive it. The flight is actually a relatively small piece of that entire puzzle. So what the military has is saying, for example, everything to the left of launch, meaning how do you get the cargo that you need to be into the rocket in the first place? Like, is it already in the rocket? Is it at the same kind of storage facility, the warehouse? Is it somewhere else? So how do you figure all of that stuff out? And there's a lot of work and a lot of really smart people in the DOW looking at that. And then same as when you land, if you don't land right where the end user is, the recipient is, how do you then get it to them? And that's a lot of what we're focusing on, is how do we make sure, again, with like landing vertically, can we get as close as humanly possible to them? So that's like this kind of door-to-door metric is the kind of main KPI of Hop Aero, if you want to look at it that way.
Okay.
The speed of the rocket is like governed by orbital mechanics. So when you fly suborbital, it is governed by just, Newtonian physics. It's just known that like this is how long it's going to take. And then you have some like extra time from drag and so on. When you look at other companies in the space, they do fly fast in the sense of like, I'll give like a really common example. There's a bunch of companies that the idea is to store cargo in satellites that are going in orbit for weeks or months. And then whenever somebody needs it, they re-enter into the Earth's atmosphere. The biggest problem there is that the door-to-door time there is actually months. So you need to know well in advance what you're going to put into space. You need to go launch on another rocket. So 99% of the time it's SpaceX. SpaceX are cutting down commercial launches from other companies. So Falcon 9 is being phased out from 2028. You're going to be stuck with Starship. Starship is very, very busy deploying Starlink and orbital data centers. So you're like, people don't really realize how depending on another company is a massive bottleneck. And then you're also putting things into
also,
orbit.
Like, this is like just a small question between. It takes like up to 6 months, right? If I say I wanna there's a reservation, it's not like, yeah, next week we have a slot or I can fly you. It's like months, right? Like months time that you need to wait.
Things. That's kind of the point I was going to make, is that you're putting things into space that are not really designed to be in space. So a good example is, for example, things that have lubricants inside. Space is a vacuum environment and it is a radiation environment as well. Things like lubricants were not designed to be there, so they can boil off over time. They can get degraded. So a very complex piece of hardware that was never meant to be in space can suddenly become useless if it spends a long amount of time in space. And again, you can do some things. You can pressurize it. You can have some like radiation shielding or whatever, but you're still bottlenecked by how quickly you can launch. You also need to qualify that entire system to make sure that it's launchable. So like, you still need to show SpaceX proof that, hey, this thing that I want to launch with you is okay and safe to launch, because you have other things in the rocket. And so all of that takes a lot of time. Ultimately, you're looking at like a long time, like you're measuring it in months, going from like putting something into space. And not only that, but then when you're in space, you have to have these things in multiple different orbits, so that, because you don't know if someone's going to need the cargo near the equator or near the North Pole. And so you need to make sure that your satellite is in the right place, the right time. The only solution to that is that you have like a bunch of them, so like dozens of satellites. Our solution was like, let's just yeet it somewhere. Just put the thing into the vehicle. We have to I have to pre-qualify it as well. We need to make sure that it's going to be okay. But because we spend a very short amount of time going through space, it's measured in minutes, not in months or weeks. And so it's inherently the fastest way of getting things to other places. We've spoken to people in the Air Force and Space Force, and it's when they compare our solution to others, they're like, we have not seen how these orbital cargo satellites are able to actually solve our problems. They're a cool concept, but I don't think it actually solves the problem that the end user is trying to get solved and that the customer is willing to pay for.
Actually, then speaking of Air Force, you guys had a major accomplishment. Congratulations. What would that mean? Would that mean the contract? Because it might mean many things, right? It might be already a small step of prototyping or a testing. Like, where do you stand today with Air Force? How is your collaboration with them?
I won't go into too much detail. What I will say is that we're actively delivering on a contract with Air Force Research Labs. We're about, I'd say, 3/4 of the way through. I don't know off the top of my head. What's really exciting is that we've built out relationships, not just within the Air Force, but also a lot of the other, the branches and other teams within the DOW. And so just being able to continue developing our idea based on what we hear from conversations is immensely helpful. And we also have a pretty cool pipeline of other, I'll say, contracts and projects that we're looking at and will be converting. So we're just getting started. We're really excited about kind of our progress there.
How do you think about scaling the production? I know it's very early days, but I also assume you have some sort of roadmap in your head with Jacob. What do you guys envision moving forward? Like, what are the milestones that you're looking forward to check?
So the biggest milestone is going to be actually like building the product itself, like getting it to a point where it works and we can sell it. So we're going to be kind of in build mode, focusing on that for the next while. Once we get there, so this is where Jacob's experience very much comes into play. He, especially in the kind of Falcon Booster Reefer program, he was one of the core people of that team. And so he has a lot of really, really cool and smart insights into how to actually cut down the time between reuses and how to refurbish these vehicles. What are some things that SpaceX did well that they didn't do so well? And so we have some aces up our sleeve there. That being said, it's just like you're building hardware at scale. Obviously, to get started, you're going to need a bunch of capex. And so we've been looking at kind of being smart about where we want to do that. We have, obviously we're headquartered in California, but we have a pretty nice and big test site out in Oklahoma at the spaceport. And it's been amazing just doing a lot of our kind of testing, putting things together in Oklahoma. We're able to iterate really, really quickly over there. And so we're really trying to be strategic in the long run about what operations of the company do we do where. I think SpaceX have actually done a tremendous job kind of breaking it down between Hawthorne, and then it kind of now moving more towards Boca Chica and initially McGregor for their engine testing. So thankfully, there's a lot to be learned from, again, we stand on the shoulders of giants. We can definitely see what things that they do well and what are things that we can improve on.
Actually, my understanding is that you don't target to be reusable immediately from the get-go, right? Like it's like a breakdown. And as one of the first milestones to that is like you just want to make sure that this goes, and afterwards is the next phase that you will be looking to that, or?
I won't go into detail on that one, but it's like reusability is definitely like one of the goals we have for the immediate future.
Okay. And in the very early days, whatever you build and you test, isn't it much more ideal to be in one place? I was wondering when I saw the map and then where you yellow boxed the locations, why wouldn't you guys stay all together in one place?
So the biggest reason is that it's like engines are very loud and they can, like, obviously there's a lot of risks of like explosions, things like that. So you need to be in a place where it's a controlled environment and it's safe and you don't have a lot of kind of population centers nearby that could potentially, obviously, like, we don't want to disturb them, but we also want to make sure that we're in a place where they're not going to disturb us by complaining about noise and things like that. So the only neighbors that we have to worry about right now is a ranch of cows that's next to our test site, and they're, really cute black cows. And so that was we've been in Oklahoma at the spaceport there since I think November, December of last year. So in parallel to building our rocket, we've also been building out the kind of infrastructure at the spaceport there at our test site. And so we picked Oklahoma because it's a phenomenal state. Firstly, I feel like it's my second home at this point. I go there a lot. My co-founder goes there even more. But we were able to get a lot of support from people there on day one. We looked at a bunch of other states. We didn't feel that same level of interest from them. We didn't feel the same level of opportunities that they could provide us compared to Oklahoma.
Okay, environment.
And even
comes down
exactly,
to
it's just, and there's more aerospace companies coming to Oklahoma as well, which is really, really cool. It's obviously for us, it's kind of a validation for our decision, but it's also for them. It shows that the work that they've been putting in is starting to pay off. And so for us, it's been a kind of a no-brainer opening that facility there in the future. The problem with like testing in California is most aerospace companies are in the kind of wider LA area, so kind of LA County or Orange County. And so the closest place to test is the Mojave Spaceport. The problem with Mojave is that it's very, very busy. And so just getting space there, getting like tests scheduled it's just a lot trickier. So yeah.
So more like a pragmatic reasons. Got it. Yeah.
Yeah.
Okay. And how would you compare building this startup in Europe versus the US? Because as far as I know, the Department of War and Department of Commercials, they also have those common initiatives, a FUSE program that they dedicated $750 million to make sure that the startups are being empowered. There are so many initiatives around nuclear energy as well, just to make sure that depending on the tracks, and in your track that you guys are easily in the defense one, how do you see the support? How do they make your life way easier for young people trying to make such a meaningful change?
I actually think the US government is obviously like they're very supportive. They're obviously like a lot more advanced when it comes to defense and deep tech and things like that compared to Europe. But even if they did nothing, I think it's a cultural thing. I think just what I've seen is that attitudes in the US are a lot more open to getting things done compared to Europe, where usually bureaucracy just tends to slow things down to a crawl. And it's sort of like the default state for a lot of things is that eventually you die by bureaucracy. Not always, and so that's the thing that like since World War II, the US had this culture of building an industrial base, and obviously it was lost for, after the Cold War. It's being rebuilt, but it has this culture of builders. It has this culture of building a defense kind of ecosystem. In Europe, that's pretty much only starting to form now. I think Europe has a lot of potential. But I also think that it's definitely behind when it comes to the culture of building things and getting things done compared to the US. So of course, like there's, we could kind of get into the details of government support and all that, but I think it really boils down to kind of cultural approaches. I think there's definitely a lot of very, very smart, hardworking people in Europe, both engineers, founders, but it's that. And then it's also just the availability of capital as well, that eventually a lot of European companies end up going at like Series B or C to the US just to be able to raise the capital that they need.
Yeah.
So I think those are two just like long-term problems that Europe has to overcome.
Yeah. Yeah. And also at the same time, risk appetite and also sense of urgency, this all come down to like certain characteristics that kind of have been there for a very long time. I hope that things change in a good way. This is really, really exciting, but I am also aware of the time. A couple of things that come to my mind. Once you have this taste of entrepreneurship, which you got, and instead of pursuing further the product, back then you gave the IP and then you moved out to work on another project. What was the decision making back then? What trade-off in your head you made with that decision?
So we weren't able to raise another round of funding. And so we were trying to, this is like when effectively the kind of the impact of the COVID bubble bursting. So like the zero interest rate period was dying out. Like there was effectively a freeze kind of in, what was that, late 2022 in venture funding. It was like, even I could see all the graphs, it was like a minimum. And that's like the worst time to like run out of funding. And so our thinking was like, we can like just wrap up the company, or we can sell off the IP such that at least it'll be, continue to be developed by somebody else, useful to somebody else. We had spent, a lot of, blood, sweat, and tears building out that IP and the propulsion system and so on. And so we really wanted to make sure that it wasn't for nothing. So that was a lot behind the decision. And then I also it's like, I actually very briefly went to San Francisco and the kind of Bay Area right after that to figure out, just to talk to people and figure out what I wanted to do.
Yeah.
And I kind of realized there that there's this, I'm actually calling from San Francisco right now. people are a lot more open to you failing and just like try something different. So like if this doesn't work out, that's fine. Just go try something else. You can try like 10 things, fail at all of them, and then the 11th thing you become successful at, and then you're Sam Altman. I think in Europe, that's another thing again, that like people have this, like I have to succeed at it. I can just do one very safe thing, but I have to be good at it. Failing is like the worst possible thing. It's again, like this cultural thing. And so I really wanted to just try something else. I was telling Jacob, we were driving from the test site a couple of days ago, that like we have failed at so many things in our lives that, we could write a book or something. But it's making sure that you're learning from all of those. And that's ultimately like in the long term, all of that knowledge compounds. And that's how you get like one or two successes. And every successful person has an infinite number of failures behind them. They've just had a very small success percentage, but that's all it takes.
I think the most difficult part is when you try something new, you don't know if it's gonna work. And because if someone tells me, yes, that's gonna take off, but just be persistent, this is much easier to endure the pain. Because then I know eventually whatever I go through now is gonna be like worth it. But I don't even know it's gonna be worth it or not. Like when is the right time to... There's this nice visualization. Have you ever seen the guy keeps digging?
Yeah.
And actually the gold mine is there, but he stops. He's like, nah, that's bad luck. I can't do it anymore. And if you
like
just went into a bit more.
In the casino, you're always one roll away from becoming a millionaire.
That's a very good one, actually. You told me that. I really want to honor that. You mentioned that as an outcome of our conversation, if one person, especially in the universities, especially some young person somewhere in this world, listening and changing their mind, that would reach the purpose of our conversation, what would that thing that you would have inspired or help them understand better, or trigger a question in their head so that they can see the word differently?
I think so. There's a lot of really, really smart kids that have like their whole life, they've worked really, really hard, gotten amazing grades. And then they like just the way that the educational system pushes you, it feels like the next step in that kind of successful ladder is going and working at a prestigious company, making as high of a salary as you possibly can. And I think it's for some people that's totally fine. But I think there is a subset of those smart kids that it is a lot of wasted potential. And you could be really, really smart and then you end up being really crappy at starting a company, but you're not going to know that until you try. Or you are very, very smart and you end up being the next Elon Musk or whatever. And so that's kind of like how I would look at that. I would just encourage people to try. I think it's worth everybody at some point trying in their lives to start a company. There is nothing wrong if it doesn't work. You just go back and you have like this 3-month period where you tried, 6-month period or a year, and then you go back to work. And if you're good at what you do, there will always be like demand from the job market for you. But you could also profoundly change your own life and just have like the most crazy adventures and just talk to the coolest people. And I like to tell people like it's like building dad lore, like just do crazy stuff. There's a very high chance that it'll be worth it. And again, even if you fail, just like the fun that you will have had and the experiences that you will have gained will always be worth it.
Yeah, I totally agree. And also at the same time, as you said, you might be very capable, smart, but if you're in the wrong environment, if you don't keep experimenting things, you will never know. Then you will think that, oh, that is me. Perhaps I thought I was different. I had a university professor who used to say, there's nothing wrong being a puppy or a kitten, but if you put the kitten among the puppies, the kitten will always think, oh, I can't bark, I can't be loud and so strong. Or if you put the puppy among the kittens, the puppy is going to think something is wrong with him and he will try to adapt. So therefore, perhaps you should find, if you're a puppy, we need to find the puppies. If you're kittens, we need to find the kittens. So I don't know, a little silly example, but does it make sense to you?
Yeah, for sure. There's a lot of different ways of like putting it. I always just think, just do it. Like just do it. And it's like every successful person that I've ever like watched them talk or seen a podcast or whatever, like pretty much the message is always consistently the same. I've never met like a really cool founder who's like, don't do this. Like, I think that it's obviously hard. Like you're going to have, hardships no matter what you do. It's a part of the game.
When was the time somebody showed faith in you and then that kind of opened a new door for you? It might be in your most difficult times. Okay.
So many. I've had so many people in life being willing to pay it forward and introduce me to people or take a chance on us, or, whether that's like as an investor or advisor, or, even hires, like just people being like, you guys are crazy, but I want to work for you. I've had so many people, especially when I was younger, I would be nowhere. I am nobody without these people who have come before me. And all I can do is hope that one day I can be the same for other young people. I think, as I said at the start, we all have moral duties to some extent. And I think this is one that if you've learned something, you owe it to the next generation to pass it on. I have like so many people to be thankful and grateful for, that it's really hard to like list by name, because I don't want to put anybody ahead of anybody else. But these people know who they are, and they know that I deeply appreciate everything that they've done.
Awesome. As a closing, we always have a question from one of our previous guests. And this time, for you, we have a question from Jamie Gall. Jamie Gall is an ex-SpaceX engineer, YC Winter 2020 batch. He also had done 2 hardware startups. And his question for you is the following. But I need to read because I don't know by heart. What's something that was consensus but is now contrary, or vice versa?
Ooh, that's a very good one. This is like oddly specific. I remember back in like the early 2020s, like 21, 22, there was a consensus that space, like orbital transfer vehicles. So this is kind of like things that are like Ubers in space that move satellites from one orbit to another, that was going to be the next big thing. And this is one thing that we wanted to pivot to in our last startup, and we were kind of pursuing it towards the last end. And there was so much venture capital poured into this, so much like hype and attention and everything, both in the US and Europe. And now there is like pretty much like 2 companies that are successfully doing all of this, from like 20 or 40 that were initially doing it. And it was like, at the time, it was like, you could not be more consensus than that. It was like, if you're not doing space mobility, you're not doing orbital transfer vehicles, you're wasting your time, that kind of thing. And that's one thing that I've learned from my experience, is don't just chase what other people are doing. Like I was younger, I was a lot more stupid. I'm like I'm still stupid, but less stupid now. And I've just learned to like always critically think about things. It doesn't matter if like everyone's, people think that if everybody thinks something, they cannot be wrong, because surely all of these people, somebody's done the research and the homework. And that's how you end up having things like ExxonMobil, and how you have Bernie Madoff, and how all these things can happen, and how orbital transfer vehicles can come and go. And so I've definitely learned to like listen to people's opinions, value people's opinions, but also not like do your own digging and do your own research.
Yeah,
exactly.
This is an excellent way to say. Is there anything that I didn't touch base but you wanted to mention?
No, I think this was a great conversation. Really appreciate you having me on. Yeah, thoroughly enjoyed this.
The same here. Thank you so much for the work you're doing and for inspiring so many people, including Nika and me here. We really appreciate it. And thank you for your honesty. Totally cool. Very cool.
100%.
All right. Thank you.
Thank you so much.